Okay, we start now, yeah? So we are going to learn about the gravitational potential. So the unit is joule per kilogram. So if you remember gravitational potential energy that you learned at secondary, m times z times h. So if I say joule per kilogram is equals to z times h. So the z, you already learned it. The formula for z, negative gm over x squared times x, right? So the height is a distance measurement, so it's x. So gravitational potential, the symbol looks like a fork. So the gravitational potential is equals to negative gm over x. Gravitational potential, the formula is given by negative gm over x. But this is not really a correct way to derive it. I just make it simple so you can remember the derivation. Now we go to the definition. So the definition of gravitational potential is work done per unit mass. So to bring a unit from infinity to a point. Usually no one understands that. I have to draw. So the x is the distance to the center. When the x is infinity, we have gravitational potential equals to negative something divided by infinity. So the gravitational potential is 0. So this is like a number line. When you are at position A, your gravitational potential at A is 0. So means before you reach A, the value is a negative value. It's like a number line. So if in mathematics you draw a number line, if the right hand side you hit 0, means the left hand side all a negative value. So means when we are leaving a planet, its gravitational potential is increasing because it changed from more negative to less negative to 0. Or we can say the potential energy is rising also. But the kinetic energy is decreasing. So if you project a rocket, right, when it go further, it will become slower. And when it reaches infinity, it will become 0. The speed will become 0. So do you have any question that you want to ask?
So can you explain the infinite one again?
If you divide the things with infinity, you get 0. So the gravitational potential at infinity is 0.
Okay.
Then, if the term is gravitational potential energy, if you want to count gravitational potential energy, find the change in the gravitational potential, then you multiply with the mass of the object that you move from this point to another point. So the question is, Can we still use the GP formula, which is mass times gravity times height? You only can use this formula if the height that we discussed, right? If the height is so much lesser than the radius of Earth. So let's say you raise the height of an object to 1,000 meter or 10,000 meter. That number is very small compared to radius of Earth. So yeah, of course we still can use the MGH formula. But then when you project something to outer space, when it's very far away from Earth, the formula MGH is no longer valid because the Z itself, right, is no longer 9.8. So you have to use this formula. Any questions?
Sir,
Yep.
what is the triangle with the
Change. Triangle means change.
no beside the triangle, sir?
That is the symbol for gravitational potential.
So the to find that one equals to negative Gm/x, yeah.
Yeah, the gravitational potential is negative Gm over x.
Oh, okay, sir. Thank you.
Okay, hold on. You can take which of this first before I give you calculations example. So, for example, number 1.
Sir, I haven't written. I mean, I haven't taken. Okay, then.
Let's say for equation number 1, right? Let's say at first the object is at the surface, right? Then now you project it. So let's call this as point A, and the planet is Earth. So what I mean by the change, right? You have to find the gravitational potential at A first, which is negative Gm of Earth, right, over the axis is R. Then if you find the gravitational potential at B, it will be negative Gm over 5R, because always measure from the center. Then you can find the change. So the change, right, is up to you. You're gonna take A minus B or B minus A. But then if you get a negative value, you can just ignore it. It's up to you to take A minus B or B minus A. So when you get a negative value, you can ignore it. But you should always understand one thing. Just now I told you already in the beginning, if you go further from the Earth, right, your potential energy is increasing because it's going from a more negative value into a less negative value. So when you move from A to B, your gravitational potential is increasing. To find the change, it's up to you to take A minus B or B minus A. So now let's say you have the change right here. You can use the change right to count the GPE of the rocket. For example, you project a rocket. So if you're going to find the GPE of the rocket, right, you're going to take the change that you have calculated, then you multiply with the mass, but not the mass of Earth. So you have to multiply the mass of the rocket, the one that you move. That's how you find the gravitational potential of the object in the higher level. Any have questions so far until here?
So,
No questions. Okay, no questions, I continue. Now we're going to discuss escape speed. So before I discuss what escape speed, right, you have learned about orbital speed, square root Gm over x. That's for orbital motion there. That's for orbital motions. So don't get it wrong. Now we are going to discuss what escape speed. So when I say escape speed, the definition is like you are projecting a rocket right from the Earth, right, and they have to leave the Earth gravity. So that's what I mean by escape speed. Yeah. So meaning, right, the things that you project will be located very far apart. Right? The things that you project will be located very far apart. You understand? So if I project it to infinity, I can say the gravitational potential is if I project the things to infinity, the gravitational potential, not the gravitational potential energy, the gravitational potential is 0. Anyone have questions until here? The initial gravitational just now is how much at the surface of the Earth? The initial is negative gm over r, right? So when I say the change, how do you find the change in this case? I take the final, yeah? Final is 0, right? The initial is it. So the change is Zm over r, right? So means if I find the GPE, it will be the change, which is this, multiplied with the mass of the object. That is the GPE of the object. Any questions until here?
No, sir.
To get the GPE, if you don't apply a kinetic energy, if you don't use the fuel to move the rocket, will he be able to gain the GPE? If there is no fuel, if there's no kinetic energy at the first place, you won't get any GPE. So your GPE is actually coming from KE. The kinetic energy of the rocket, when you launch it from the Earth, right, is being converted to the GPE. How do you calculate the kinetic energy of the rocket? Half times it.
mv square.
mv squared. And as you can see it here, the mass of the rocket is not important. So when you want to launch a rocket, right, it doesn't depend on the mass. The escape speed, you times 2 to the other side and then you root it. So the escape speed is given by so the escape speed of an object depends on the mass of the planet and the radius of the planet. So the one that I write in the blue marking at the left side is this one, A and B, and because it have a certain position. But then at the escape speed discussion, they have to reach infinity. That's why the gravitational potential is 0. If not reach infinity, the gravitational potential cannot be 0. Any questions?
No.
No. You can take a picture of this. I will like share some questions so you can try to do later. So later from the same paper that I sent to the group or sent to you just now, you do number 3, number 5, number 8.